Okay, so today we're getting presentations from the Rocking Riptides, the Seven Seas, and the Danger Zone. So could the Rocking Riptide presenter please identify themselves, and I will give you permission to share your screen. Hello, Riptides.
I am not the one sharing the screen, but I am part of the group.
So you have to have one person designated to share the.
I don't think she's here right now.
Okay, who is it?
It's either Tara or Sage.
Tara or Sage? Tara or Sage are from the Riptides? Well, you better text them to make sure that they get on, because you're supposed to be first up. What about the Seven Seas? Is there somebody from the Seven Seas here who's going to be presenting?
Yes, I'll be sharing my screen.
Okay, Kat, I'm making you a co-host.
Awesome, thank you.
And possibly if the Riptides aren't ready, I will ask you all to go first, if that's okay. Would that be all right?
Yeah, that's fine. I think we thought we were going first anyway, so.
Okay, it's a little hard to tell from the way it's written.
Yeah.
All right, so, and then Danger Zone is the third group which is presenting today. Who's going to be showing slides for Danger Zone? Hello, Danger Zone. Hello, Danger Zone. You're in danger here, Danger Zone. Somebody here from Danger Zone who's going to be showing slides? Phew. I hope we're not running out of steam here on the last mile. Okay, so far I've got the Seven Seas. Hey, Carrie, would you please send, are you on board, Carrie?
Yeah, I'm here.
Can you please send group emails to both Rocking Riptides and the Danger Zone, just to make sure everybody gets it. I guess we got some folks here from Riptides, but Danger Zone, are you here? So send them emails, tell them they've been able to log on here, or they risk not getting points for this presentation.
Okay, I'll do that.
Thank you.
Hello, Professor McDonald. Danger Zone is here.
Danger Zone. Okay, so glad you made it. All right, are you going to be presenting, April?
No, I'm not. Isabella McLean will be. Are we first, second, or third today?
Well, you're either going to be second or third. Is Isabella on board?
I'm not sure yet.
Well, you better text her to see if she can't get on board. And I guess then we'll start with Seven Seas. And both the Danger Zone and the Rocking Riptides need to reach out. And when you find out who is going to be presenting, send me a message in the chat, so I'll be able to make that person into a co-host so that they can present when your time comes.
Okay, thank you.
Okay. All right, so okay, so Seven Seas, why don't you go ahead and share your slot, share your screen, and we'll be ready for your presentation. All right, so you probably want to make it into the present mode. Very good. Okay, so the effect of plate tectonics on global ocean circulation and climate. Cool. All right, guys, take it away.
Okay, so as you said, we're presenting today about plate tectonics and the impacts on ocean circulation and climate. It's a pretty broad topic, so we're going to start off with some background and then use the Drake Passage and the Central American Seaway closure as examples to demonstrate our point.
Plate tectonics act as the driving force behind many of Earth's processes and are able to influence oceans because of earthly interconnectedness. Plates are slabs of rock that float across the asthenosphere due to differences in density. They move in part due to convection and spreading events, leading to the development or destruction of lithospheric plate. This results in the creation of phenomena such as mountain ranges, volcanoes, deep sea ridges, and so on. Again, because of the interconnectedness of Earth's systems, tectonic activities not only change the surface appearance, but oceanic processes and adjust to them as well. So how do plate tectonics influence ocean circulation? We understand that ocean currents are a means of transporting the heat energy from the sun to regulate and distribute that energy. Gateways are exactly what they sound like, a passage that kind of opens and closes, distributing the usual circulation of the ocean. Later, we will go into two of these gateways in particular, but they're usually a narrow channel with varying depths. Now, when I say they open and shut, it's not a literal cutoff, as in the stopping of ocean flow. Instead, plate tectonics pinch or widen the area, causing an alteration to the circulation. This is kind of like a game of pool in that which the angle or placement of a passage changes, similar to a ball being in a different position. It will change the path it will take, maybe banking off of different walls and ending up in a completely different position. This is also known as the geometry of the ocean, or how these currents kind of bounce around.
Okay, so I'm Sammy. I'm going to be talking about plate tectonics and climate. And so first I wanted to preface that plates take a long while to move. So when I'm talking about plate tectonics and climate, I am first talking about what the movement of the plates actually generate, and then what those varying situations actually affect the climate. So with that, I'm going to give a couple of examples. So with more continental ice sheets, an increase in albedo would occur. So in turn, more sun is being reflected back out to space, which would lead to an atmosphere cooling. When plates collide, mountains can be built. When mountains are generated, chemical weathering occurs because of the new exposed rock and soil, which leads to atmosphere cooling because of the encouraged carbon dioxide cycling. When more plates collide, the generation of volcanic activity occurs, and when volcanoes erupt, an increase in carbon dioxide emissions occurs, which leads to the atmosphere warming. When the eruption is large enough, the mass amount of ash acts as a blanket, shielding the sun from the earth for a period of time, which leads to the atmosphere cooling. When plates collide in the ocean, oceanic currents change, and since this movement is disrupting the natural flow of water, the energy has to go somewhere, so it generates heat. Next slide, please. So volcanoes. Volcanoes release less than 2% of the equivalent amount of CO2 released by human activities. So what about when these volcanoes erupt? So once about every 20 years or so, there's a volcanic eruption that throws out such a huge mass of particulates and gases that it shields us from the sun, which leads us to a period of global cooling. This blanket will usually dissipate after about 2 years, but the effect is nearly global. Oceanic currents can pull different materials, plants, different marine organisms, as well as heat to other coasts. And when you introduce anything new to a location, it has the potential to do good or do damage. And it's also very possible to introduce something invasive without even knowing it. This could disrupt local climates. And this graphic on the right, it shows where mountains were being built and oxygen is being increased because CO2 is being decreased with the carbon cycling.
So how is it possible to measure something that happens on such a global scale? Well, through our research, it's been made clear that there's literally dozens of ways to study plate movement, and it depends if the plates are in the sea or above sea level. One of the tools used to do so are seismographs, which measure vibrations during earthquakes, but they can't really detect subtle shifts of the plates. So in the 80s, GPS was adapted to fill this gap, which is performed by installing geodetic markers in the ground and tracking the displacement of the plates on which they're located as years pass. In 2006, Dietmar Müller began to build G-Plates, which is an open source software that allows pretty much anyone to reconstruct Earth's plates. Now, we're able to study and map the ocean using multi-beam bathymetric data, which measures the travel times of sound waves from the surface to the seabed. telling us things like the depth of the ocean and the shape of the Earth's crust. Scientists have also recently applied space measurement techniques like SLR, DORIS, VLBI, and GNSS, which measure signals from Earth to deep space radio stars with the accuracy of a few inches, which is incredible. This opened a world of opportunities for geologists to theorize about the geologic past. We use all these tools to study the history of geologic features such as the Drake Passage. Around 41 million years ago, the South American continent split from Antarctica and created the Drake Passage. A few million years later, Australia and Antarctica did the same thing and formed the Tasmanian Seaway. And what this did was basically isolated Antarctica from any other continent and completely reconstructed ocean circulation. And it prevented warm surface water from the lower latitudes by the equator from reaching Antarctica through something called the Antarctic Circumpolar Current. The ACC is one of the most unique currents in the world in regard to its geometry, kinetics, dynamics, and seasonal changes. It is made up of 7 different water masses, which combine to play an important role in the world's climate system and the ocean circulation. So if you think about it, if the continents didn't shift in the way they did, there would be no Drake Passage, no Tasmanian Gateway, no ACC, which means no continental ice sheet, and likely the climate would be a lot warmer. The Drake Passage has been studied intensely the last few decades because of its interesting complexity, with studies such as the Drake 79 experiment providing the most abundant data. These data reinforce the importance of the Drake Passage in our global ocean and atmospheric circulation systems.
So I will be talking about the Central American Seaway Closure, or the CAS. And the Central American Seaway Closure was a closing of an oceanic gateway located in the current countries of Panama, Costa Rica, and Nicaragua. It connected the Caribbean Sea and the Pacific Ocean. It was initially formed by the subduction of the Farallon Plate, later the Cocoa Plate after it broke up, under the Caribbean Plate beginning around 72 to 50 million years ago. This arc would then collide with South America, forming a chain of islands. And so this Isthmus of Panama gradually formed from this island chain. And as you can see from this diagram, it took millions of years and would occasionally open up as it continued to form upwards. So the seaway was nearly likely closed by around 2 to 3 million years ago, but evidence points towards shallow areas still existing, and there's evidence of exchanges of marine plankton, providing evidence that powerful currents and storms would occasionally connect the bodies of water. The evidence for 2 to 3 million years ago include a regional extinction event around 2 to 4 million years ago in the Caribbean, which was more selective to species reliant on an environment of higher plankton productivity, like that found in the Pacific Ocean. Other evidence includes a divergence in the surface salinity of both the Pacific and Caribbean around 4.2 million years ago, which suggests the seaway was mostly closed by this point. By 2.7 million years ago, the seaway had closed to the point of consistent land transmission of animals and plants between North and South America. This led to the Great American Biotic Interchange, or GABI, which significantly impacted the ecologies of the Americas. Much like Australia, South America was a land of unique biodiversity, as it had been cut off from the rest of the world for millions of years. Once reopened, species flowed in and out of the continent. Notably, opossums and porcupines would spread into North America and become native to this region. Next slide, please. The timeline of the closing of the CAS is significant in how it corresponds to the Pleistocene Ice Age, as you can see on the right, which occurred around 3.2 to 2.7 million years ago. However, correlation is not causation. Though it has been theorized that the seaway closure caused this glaciation, it likely had a smaller and more nuanced impact. Specifically, the seaway's closure rerouted water to flow around the Drake Passage and through the straits between Brazil and West Africa, where it would warm for longer than if it had flowed to CAS. This warm water set the stage for higher precipitation in the North Atlantic and North America, which helped provide the conditions for glaciation and accelerated it once it was underway. Along with this, the CAS closure likely strengthened the Atlantic Meridional Overturning Circulation, or AMOC, in the North Atlantic. The AMOC is part of the thermohaline conveyor belt, which is the flow of waters of different temperatures, salinity, and density around the world. It is specifically characterized by warm, salty surface water moving north and deep, cool, pressure water moving south in what we call the North Atlantic deep water. The closing of the CAS likely strengthened this cycle with an influx of new, warmer water when it was weaker than we know it today. Next slide, please. The lack of a Central American seaway is very significant in our local and regional climates, as it results in a stronger AMOC and thus a stronger Gulf Stream. The effects of the Gulf Stream on our climate are significant in how it both moderates the temperatures of peninsular Florida, as well as how it provides strength to tropical cyclones that move over during hurricane season. Along with this, the Amok is a significant carbon sink in the North Atlantic, and the consequences of this closure affect more than just the climate. It also changed the native ecology of our local region, with the Great American Biotic Interchange radically changing the ecology of our region, and with the introduction of new species of opossum and porcupine. This closure also resulted in the regional extinction event that distinctly changed the Caribbean's ecology.
Hi, my name is Josh. I'll talk to y'all a little bit about the impacts of global ocean circulation and plate tectonics on biodiversity. So the simple concept behind this is that changes in gateways affect ecosystems and their ability to migrate. Really, this is simply areas being exposed to each other that were not before due to changes in plate tectonics, sea level, and also global ocean circulation. These changes can either increase or decrease biodiversity. One really fascinating example of changes in biodiversity due to shifting plate tectonics can be found in the example of the Trans-Arctic Interchange. I'm sure we're all familiar with the concept of the Bering Strait and how it's theorized that humans made their way over from Asia into North America when that was a land bridge. But as sea levels rose, obviously the Bering land bridge became the Bering Strait, which is now it's a body of water, a pass through between the Pacific and the Arctic Ocean. Before the species in the Arctic and the Pacific Ocean, before about 3.5 million years ago, it's theorized, were completely separated by this sort of natural land bridge. But as sea levels rose, this land bridge became a body of water, and this biotic interchange was able to take place between the Arctic and the Pacific Oceans. This had some very interesting consequences that Professor Hirot Vermey discussed in a paper of his. And one of the interesting things that he found was that it seems that evolution was significantly greater and more varied among the Pacific originated species than as compared to the Arctic species. So even though there was interchange between he was studying specifically mollusks, but even though there was interchange between the Arctic and the Pacific Ocean, it seemed like there was much greater variety that came out of this interchange in the Pacific originated mollusks than in the Arctic. And this is theorized for a number of reasons. One of them is potentially the fact that because the Pacific Ocean has sort of it's much bigger. There's a greater range of temperatures and whatnot. That these creatures were just more easily adapted to their changing environment. In addition, global ocean circulation and climate also have a great impact on humanity and our cultures. It's estimated that around 40% of the world population lives within about 100 kilometers of the coast. And so obviously this huge number of people would be most heavily affected by circulation. But it also, the oceans affect everybody around the world and not just those that are by the coast. Some obvious examples of the ocean circulation effects on humanity we've already discussed, with the ocean's ability to absorb great amounts of solar energy and transport that heat and moisture throughout the world. In addition, the evaporation of ocean water leads to storm formation. We can see this pretty clearly here in Florida during the summer with our, it seems like just about every day sometimes we get a storm that rolls through. That's just one example of how ocean circulation affects where we live right now. And this obviously is not local to Florida, but goes on all throughout the world. As you've also discussed in this class, we've learned about the North Atlantic gyre and trade winds and how people have used those for transportation for hundreds of years, in addition to the jet stream being used for travel more recently. One specific example that I found kind of interesting about that pertains specifically to ocean circulation is in the Indian Ocean with seasonal monsoons and the effect that those have on people. The monsoons in India are hugely important to the success of crops like wheat and rice. and let's see, sugar as well. And if there's a successful monsoon or rainy season, then the crops will do well generally. And if there's not, then it'll lead to famine and great economic problems in a country of about 1.3 billion people. So all that being said, I think the parallels between ocean circulation and climate are very easily drawn to the health and wellness of people all around the world. And these are just a couple of examples, but obviously this happens everywhere. Next slide, please. Oh, sorry. That was the one I was just presenting from. Next slide. Then here are our multiple choice questions. If anybody has any questions, please feel free to ask them now.
Okay, well, thank you, Seven Seas. That was a broad-ranging report. We got questions from the audience? Give them something to ask and talk about. Come on. No questions? There's a lot of material there. Well, I had some questions. You sure there's no questions from the audience? Okay, well, I was wondering about what you guys thought. This is sort of a thought question. What do you think is next in terms of the effect that plate tectonics is going to have on climate and ocean circulation? Can you make any predictions about the future, say the next couple of million years, what Earth is likely to have?
I know that the Mediterranean is like shrinking as the African plate moves north. So in a broad sense, the Mediterranean may disappear in a few million years. Maybe not a few million years, I don't know the actual timeline, but that is a process that is currently happening, I'm aware of. What
about the rifting of the Red Sea? Do you think that would have any effect? Because
Yeah,
the Red Sea is continuing to rift apart, right?
yeah, and the Great East African Rift Valley? That's splitting apart, isn't it too? That's another
Yeah,
thing
well, most of
in next
the
million years.
movement is in the Red Sea, so the Rift Valley is stalled at the moment. But so if the Red Sea were to open, what would that do you think?
There was a sea there before. It wasn't a gateway we touched on. The Tethys Sea was there.
Yeah,
And it was a
that's
gateway
right.
that shut.
Well, when
And-
the Tethys Sea was there was a equatorial seaway. So that would have, what kind of conditions would you have had on Earth if there was an equatorial seaway?
I mean, I would theorize that it would be generally more warm and more humid.
Right,
And there
because
there
you'd
wouldn't
be
be a
trapping
circumpolar.
heat in the global circulation there.
Yeah.
Okay, interesting. And then another question, I was a little unclear when you were talking about the Bering Seaway, Josh. So how is that directly related? Is that what's causing the opening and closing of the Bering Seaway? Is that plate tectonics or is that something else?
So I believe the opening and closing of the seaway was caused by glaciation and ice melting from the ice sheet. So it wasn't directly necessarily directly connected to plate tectonics, but I think there's still a connection there. But yeah, you're right. It was glaciation and melting and rising sea levels.
Right. Well, I mean, so we could think about that a little bit. So when the gateway between North and South America closed off, that produced what James was saying. What happened generally, to global conditions?
There was the Pleistocene Ice Age.
The Pleistocene Ice Age. So Josh, with the Pleistocene Ice Age, what happens to the Bering Sea Bridge?
That bridge would open back up. The land would be above the water. Basically, people could pass through, and that's sort of theory.
So yeah, so that's the connection there, isn't it? Potentially is that that loss of the American seaway, the Inter-American Seaway there, and then potentially the beginning of the Pleistocene ice ages. So Okay, well, I think we'll have to leave it there, but that was very interesting and far-ranging, and you brought out a lot of things that we didn't have a chance to cover in class. So thank you very much, and those questions will be part of everybody's future. All right, thank you for the presentation there. And the next up, I guess, Rocking Riptides, are you ready?
Yes, I believe so.
Okay, Rocking Riptides, Sage, take it away.
All right. Oh. Can you guys hear me?
Yeah, go ahead.
All right, perfect. Hello, everybody. Today we will be discussing the major adverse impacts on the Great Barrier Reef and its possible repercussions, not only locally, but globally. My name is Fox. So first, what is the Great Barrier Reef and where is it located? The Great Barrier Reef is the world's largest coral reef on the north to northeast coast of Australia. The reef stretches for around 1,430 miles. The coral reef is home to hundreds of species of coral with thousands of species of fish, calling the Great Barrier Reef home. However, as we are about to discuss today, we are slowly destroying the reef. Overfishing and damaging fishing practices are destroying natural habitats that these vast populations of species live. Despite the reef's ability to naturally adapt and evolve, if these conditions continue, the reef will suffer and local communities won't be able to live and profit off of fishing and the coral reef because we are slowly damaging these coral reefs. And the damage to the reefs have been greatly caused by the rapid growth of global warming. And this global warming, of course, is causing the climate to change drastically. So to start with, climate change has been a constant natural battle with very little results or improvements, especially since the Industrial Revolution. People have been pumping carbon dioxide and other greenhouse gases into the atmosphere. Only since 1988, however, this issue has been considered a national issue. Increased emissions of greenhouse gases have slowly been damaging the ozone layer, allowing for Earth to heat up at a much quicker rate. This heating also affects the temperature of the ocean. This temperature change dramatically affects anything that lives in the ocean because of species of animals can only live in a certain average temperature range. And if they do not live in this certain average range, this kills populations of corals, animals, and planktons. And despite having natural cycles of warming and cooling, this warming is greatly affecting the environment, despite having the Earth having natural cycles of warming and cooling over many of years, with us pumping these gases, we are only growing, the Earth is only growing in warmth. Now, carbon dioxide is considered the most abundant greenhouse gas in the atmosphere. However, carbon is used in photosynthesis to convert to oxygen. However, the use of carbon, if there is too much carbon in the atmosphere, like we are continuously pumping in, things like plankton cannot absorb it as much. And as you can see in this image, excess carbon dioxide that gets absorbed in the ocean causes what we know as ocean acidification. And
Okay, next slide, please. Okay, so speaking of ocean acidification, it shifts the chemistry of the water as there is an increased uptake of carbon dioxide in the surface layers of the ocean, which has a negative impact on vulnerable ecosystems such as reefs. Carbon dioxide in the atmosphere now exceeds 400 parts per million, which is 50% higher than what it was prior to the Industrial Revolution. As carbon dioxide enters the waters, the majority of it produces bicarbonate and hydrogen ions. With larger amounts of carbon dioxide, the excess amount of hydrogen ions lowers the pH of the waters. The concentration of carbonate in seawater decreases as the hydrogen combines with carbonate to produce excess bicarbonates.
This prevents biological structures such as coral reefs from receiving the amount of carbonates they need, resulting in a decreased rate of calcification. And as corals become weaker, they're less likely to withstand damage from other organisms, atmospheric changes, and storms. With changes in pH of oceanic water, decreased carbonate ion concentrations, and higher rates of erosion, it's observed that coral reefs are declining in growth and diminishing. Among the reefs, the Great Barrier Reef is the largest living system in the world. It's predicted that with only an increased change of 1.5 degrees, 70 to 90% of the reef will be weakened by ocean acidification. Loss of coral cover will lead to a decrease in biodiversity and less protection from storms. However, since the Great Barrier Reef is not heavily relied on for food and there's some room for adaptation, there's a chance for the ecosystem to be more resilient to environmental change than others.
So another thing that can affect coral reefs is water quality. There's expected to be a global increase in storm intensity, with winds being 5 to 10% faster and average rainfall rates increasing by 4 to 27%. The heightened intensity of storms will increase water turbidity, which can block out sunlight and decrease photosynthesis. And then the increased storm surges can destroy coral reefs by force. This was seen in 2011 when Cyclone Yasi, which you can see a picture of it to the right, hit the Great Barrier Reef. Along with the mass coral bleaching event, we saw a decrease in 50 to 80% of coral cover after Cyclone Yasi. As cyclones gain intensity in the near future, we can expect more and more sections of the Great Barrier Reef to be wiped out in a matter of a few hours. And turbidity can also come in the form of agricultural runoff. And this has the potential to harm coral reefs due to a mixture of sun-blocking sediments, as well as eutrophication stemming from increased nutrients. And in Australia, 95% of their sugarcane industry operates within the catchments of the Great Barrier Reef. And you can see a map of that below on the right. But the good news is that over time, corals that were exposed to increased turbidity had the opportunity to build a resistance to things like temperature increases and bleaching events. This opens the opportunity to create new reefs through replicating the genetic makeup of resistant coral.
Okay, so talking about coral bleaching, as water warms due to climate change, there's higher observances of this. Corals and algae living within them, known as zooxanthellae, depend on each other for survival. Under abnormal conditions such as warming waters, the algae produces toxins that are harmful to both parties. The coral expels the algae permanently, and they're left weak and vulnerable as that algae is a primary food source. Since coral tissue is transparent, they appear white without the algae cover, which gives the process this name. There's a number of factors that can lead to these events, such as UV exposure and lowered salinity, but recent events correlate directly to a rise in temperature. In the Great Barrier Reef, results show that coral bleaching is a large contributor to the decline in coral cover, as it has lost over half of its corals in the past 25 years. Coral bleaching alone will not cause the loss of the reefs, but the process that greatly weakens the corals paired with other destructive activities such as storm events can lead to permanent loss.
So like Tara said, coral bleaching is only one cause for the deterioration of coral along Great Barrier Reef. Coral reefs have developed and survived disturbances before with no permanent loss, such as from powerful hurricanes that can break apart the coral, predation from natural predators such as sea snails or starfish, or even natural warming of the waters from events such as El Nino. The problem is when the coral is not given sufficient time to recover from the stressing period. Coral requires a long enough resilience period to recover from disturbances, and if not given enough time, will die out and deteriorate. The recovery period for coral after major disturbances is typically within 9 to 12 years. But when coral experience accelerated disturbance rates from both natural and human disturbances, they don't have enough time to recover. Human disturbances can include actions such as oil drilling, local pollutants entering the water from runoff, and overfishing of species, all of which affect the coral in different ways and create scenarios where the coral isn't given a chance to recover. It was found that after a mass bleaching event in 2017, reproductive material was down 89% in 2018 in the Great Barrier Reef after a major spawning event. Next slide.
It's not switching. I don't know why.
Okay. For coral recovery, it requires a monitoring of both deep water coral reefs and shallow tropical coral areas to determine the entire picture of how coral is recovering. Deep water coral, while lacking the diversity seen in coastal areas, still cover an extremely large area of the ocean floor and need to be monitored to understand how the coral is recovering. These coral reefs grow slowly over long periods of time, which makes measuring their total cover, which is a main determinant of age, a struggle. Satellite imagery and maps can be used to measure and determine large-scale coral cover, with an example being the Millennium Coral Reef mapping project created by the Institute for Marine Remote Sensing at USF. This uses high-resolution images gathered over many years to create an accurate landscape for shallow coral reefs. There are many other ways to monitor coral reef restoration and recovery. These are outlined in a guide released by NOAA to assist both local and large-scale areas and programs with determining how well coral can be recovered. Factors for coral environment measurement include coral cover area, genetic diversity of remaining coral, and measurement of live tissue remaining on coral over large periods of time.
Now that we've shed some light on climate change complications the Great Barrier Reef is facing, such as coral bleaching and ocean acidification, we must discern what repercussions this will have on the Great Barrier Reef's fragile commercial fishing community. There are thousands of people living in coastal towns whose livelihoods are dependent on the Great Barrier Reef. The abundance and variety of reef fishes living within the Great Barrier Reef, GBR, are a source of a $6.1 billion regional tourism industry. People all around the world visit the GBR to marvel at the colorful corals that are teeming with thousands of different fish. The GBR also supports commercial and recreational fishing industries that produce an estimated $145 million and $610 million per year, respectively. These industries play a crucial role not only in the Australian economy, but also in the social well-being of the people who depend on it. The regularity of coral bleaching on the Great Barrier Reef is anticipated to climb as sea temperatures continue to rise. This in turn will diminish the diversity and abundance of reef fish as well as change their species composition. This will be because of the coral bleaching effects discussed previously. A few reef fish species are coral dwellers. Some feed on live coral and many make home in live corals. These reef fish are species that are most immediately affected by declining coral cover and are estimated to be around 10% of the total fish population in the GBR. Despite the fact that only 10% of the species have a direct dependency on the GBR, the decline of coral cover will have a negative effect on the energy transfer throughout the entire reef ecosystem, from phytoplankton to large pelagic fish that are sought after by the fisheries. For instance, there are herbivorous reef-dependent fish that eat macroalgae, which would otherwise grow uncontrollably and smother corals. Undoubtedly, such radical changes in fish diversity and abundance on the GBR that stems from climate change will also have a massive effect on commercial fisheries. The most profitable fish that are sought out by GBR fisheries are coral trout, red throat emperor, red emperor, tropical snapper, and Spanish mackerel. These are species in higher trophic levels than most reef fish, so they will not be as directly dependent on the corals. However, this does not mean they escape the detrimental effects climate change is imposing on the GBR. It is speculated that changes to primary and secondary productivity in plankton due to climate change could flow on to species in higher trophic levels.
So when we talk about the fishing industry, we also need to bring up the issue that is overfishing. Overfishing occurs when a population of fish is removed from their environment faster than they are able to reproduce and replace themselves. The loss of a species can result in a cascading effect, wherein the predator or prey population of the lost species are affected. This can have a long chain of population growth and shrinking throughout the entire food web. While fishing in the Great Barrier Reef is well managed today, it wasn't always that way and is still affecting the reef today. An example in the Great Barrier Reef is one over 50 years in the making, and it is that of the great Triton snail, Charonia tritonis, and the crown of thorns starfish, Acanthaster plantae. You can see the snail above eating one of the starfish, and you can see a starfish not being eaten on the bottom. So the great Triton snails were overfished beginning in the 1970s, as their spiral shells were popular gifts. Tourists would buy them when visiting Australia and New Zealand. This resulted in the great Triton population plummeting down to a level that they still have not been able to recover from today. Great Triton were the top predator for crown of thorns starfish. So when their population dropped, the inverse occurred for the starfish. This has proven itself to be detrimental for the Great Barrier Reef, as crown of thorns starfish are known for eating the equivalent of its own individual body mass in coral every single day. Through this, overfishing has a direct correlation to the lessening of the Great Barrier Reef.
So obviously it's widely agreed upon by most scientists that as the effects of climate change and the human impacts on the ocean increase, specifically in our case on the impact it has on the reefs, changes in the way humans interact with the ocean must be drastically changed across the board. And it's easiest to just start with what we already have and build upon that. So this means adding on to adjusting or completely changing the rules, laws, and regulations that are already in place. So it's actually been found that fish populations can bounce back to normal very easily from major climate change effects like rising temperature and increased acidification. We just need to give them a push or a catalyst, if you will, and this starts with something as small as decreasing the catch limits for commercial fisheries in the area, especially for the fisheries near coral reefs. Bringing these fish populations back to normal will help the destroyed coral recover as best as they can. And another type of legislation that can be improved upon surrounds water quality. In 1981, Australia passed the Sea Dumping Act and an effort to regulate waste disposal by requiring any vessels or aircrafts to obtain a permit before dumping waste in the ocean. And as we know from previous slides, the water quality could be much worse, but it's gotten better, but it also could be significantly better. And Australia has, however, no legislation surrounding runoff or any regulations around that, which is more of a concern for the Great Barrier Reef, especially because there's already types of legislation surrounding dumping. And another thing that instead of improving upon, another way we could add legislation is, or Australia could add legislation, could be to respond to outbreaks of predators in coral reefs, much like how Florida fisheries are encouraged to kill the invasive lionfish because they harm the native ecosystems and marine life. If Australia puts practices like these in place when they notice an invasive species, especially near the Great Barrier Reef, it will help them recover much faster. And these are, I don't know why the slide isn't changing, but our questions are in the next slide. Sorry, I'll get it. So if anyone has questions, feel free.
Yeah, please ask some questions. Great Barrier Reef is one of the wonders of the world. And this is
Sorry, I have a question actually. So you had said that corals can adapt to temperature changes and bleaching. So why do you think their populations continue to decline at such a fast rate if they are able to adapt to these situations?
I think that it's super important that it does have a specific recovery period. So if an event were to happen, for example, a big storm were to happen right after they're already weakened, then if it's not given that time to recover, then it will result in permanent loss if it's not given that time to adapt.
I know with all the regulations and everything that things are improving, but is there do you believe that there is possibility for the coral reefs to get back to their full strength ever, or just always going to be recovering?
I don't think it'll ever be perfect. It's not heavily relied on for food. A lot of the damage could recover, but as long as people start to put more attention towards the issues, then it shouldn't be a terrible issue for people to start to rely on other ecosystems rather than the Great Barrier Reef. And as long as we pay enough attention to that, then we should give it enough time to recover. But who knows if that will ever happen.
okay. Well, thank you, audience. I had a couple of questions. So how much of the Great Barrier, compared to say before the 1980s, which is when you say that climate change maybe began impacting the reefs, how much is left? You know, how much of the reefs have been lost or damaged? Do you have some ideas?
It has lost like over half of its corals in just the past couple of decades, but I'm not sure exactly how much of it is left.
So yeah, it's around a half to 60% right now, and in the next 10 years, it can be over 90% if we don't do something about it.
Okay, yeah, well, that's an important statistic, right? To sort of say already up to half of the ecosystem has been altered by, and then, so how much of the alteration do you think is due to bleaching versus water quality versus overfishing versus crown of thorns? Do you have like a general sense of what's the most impactful of those issues?
The most impactful is the coral bleaching or the destruction of the corals, because with the destruction of the corals, the habitat is lost. So like almost completely, so fish can't live with the corals, and that is the main like factor.
Yeah, I would say that the ocean acidification and coral bleaching is tied to other things like water quality and stuff like that.
Yeah, I think it creates a domino effect that goes throughout the entire ecosystem.
Exactly.
Okay, and then one thing that I just wanted to, maybe you misspoke, but you said that the destruction of the ozone layer was what was causing global warming. Did you?
Sorry, yeah, no, I did misspeak there. It's not the destruction of the ozone layer. It's because of the ozone layer is slowly being destroyed. It's allowing more heat and radiation to be put into the Earth.
Well, the ozone, what kind of ozone blocks UV radiation, right?
Yes.
So there's more UV radiation coming in, but that's specifically in the Antarctic and the polar regions where the UV radiation comes in. But what does CO2 do? How does CO2 affect?
The CO2, with excess CO2 in the atmosphere, it allows, like I said in the presentation, if there's too much, we can't, the phytoplankton can't absorb it all.
Okay, but can anybody help Fox out a little bit here? I think he's got a little bit not got the concept completely down. So I mean, what do we call the process of excess carbon dioxide in the atmosphere? There's a name for that process.
Greenhouse effect.
Greenhouse effect, right? So how does the greenhouse effect do? It's not letting more energy in, it's stopping the heat energy from getting out. So it traps heat into the atmosphere. So you know, it's true that the ozone is important for blocking UV radiation in particular, and that could be a real issue. But the bigger issue, and probably what's affecting Australia more, is the greenhouse effects that are increasing atmospheric and ocean temperatures. Okay. Okay. All right. Thank you very much. And that's Great Barrier Reef is a like I say, a natural wonder. And it's really concerning. And you know, we also, Florida, you know, knows about how important reefs are for fisheries and tourism. And so we really, you know, it has to be a sort of a global effort to protect these corals, and what they're doing in Australia can help everybody. Okay, so the last presentation up is from the, well, who is left? It's the Danger Zone. So Danger Zone, please go ahead and show your slide, and let's get started.
All right,
we did the effects of nuclear waste on the marine environment. Go. So to begin with, a nuclear power plant uses nuclear fission to heat water, produce steam, and in nuclear fission, atoms are split apart to form smaller atoms, releasing energy. It's essential for a power plant to be near a water source because water can act as a natural barrier, protect against radioactive materials. You can cool used fuel, and water and extra water supplies can be used as a backup source of water for the reactor core. Here to the right is a basic little diagram of a nuclear power plant, sorry. And at each number, there's a pretty important step that goes on. So at step number 1, fuel rods full of uranium pellets are placed in water. And then at number 2, those uranium atoms split and release energy. And then at number 3, this energy heats water, which creates steam, which is very important to the nuclear power plants. At number 4, the steam moves through a turbine, which turns a generator to create electricity. And finally, at step number 5, the steam cools back into the water, which can be used all over again. And at the bottom here is a basic definition of nuclear waste, and it's the material that contains radionuclides at concentrations greater than clearance levels as established by one's country's regulations. Next.
Nuclear waste tracking varies depending on the type of facility or point in production process. For example, the regulation behind the waste from mining the materials is different than the regulation behind the materials that have interaction with the cooling rods. The International Atomic Energy Agency has highly detailed procedures for monitoring all aspects of nuclear waste disposal and are currently working on being accepted as the global standard. Founded in 1958, the agency is constantly updating regulations to create a stable and sustainable global safety regime. These regulations, for example, cover events that might lead to a loss of control over a nuclear reactor core, nuclear chain reaction, radioactive source, or any other source of radiation, and to mitigate the consequences of such events if they were to occur, like what happened in 2011 with Fukushima. Actually, also in 2011, the US Department of Energy proposed the usage of RFID tags, which is radio frequency identification, to track waste and potential catastrophes at a faster and more accurate rate. The RFID tracking sends data to a server at a data center where in the Argonne National Library, where appropriate course of action is then determined. So the kind of local relevance to all this is Florida being located or surrounded by water makes it an ideal candidate for nuclear energy. However, as more severe tropical storms become normal with the warming climate due to climate change, that might prevent nuclear energy from being a feasible option here in the Southeast United States. From fear of another nuclear catastrophe like what happened in 2011. Next slide.
So with all of these nuclear power plants, there's obviously nuclear waste that needs to be disposed of. Scientists are currently working on what the best possible way to dispose of this nuclear waste could be. As of right now, it is apparent that the decay rate of nuclear waste or radioactive isotopes when disposed of in the ocean is much faster than the decay rate of the same radioactive isotopes when disposed of on land. So when disposing of waste in the ocean, there are two possible methods at our disposal. The waste can either be dumped as a raw liquid waste or it can be disposed of in barrels. However, this method of disposing in barrels was banned by the London Convention in 1972. The leading nations in dumping nuclear waste into our oceans are the UK and Russia, and some other contributors are also the US, Switzerland, France, and Belgium. Next slide.
So next, we're going to talk a little bit more specifically about Fukushima. So the Fukushima disaster occurred on March 11, 2011, and was sparked by the Great East Japan earthquake and tsunami. It was a humanitarian disaster, and the power plant was located on the Japanese coast in the coast of Okuma, Japan, with a 6-meter seawall. It was located near the ocean because power plants, as stated earlier, use nuclear fission to heat water and produce steam. So Fukushima was a severe nuclear accident that was caused by 3 of the 6 reactors of the power plant sustaining core damage after the seawall was overtaken by the tsunami waves and hydrogen and radioactive materials were released. The Fukushima disaster has had impacts not only regarding human health, however, but also the health of the environment. A major impact that the Fukushima disaster had on the environment was the release of radioactive ions into the ocean, which caused irreparable damage to fish populations, for example. Fish populations in the Black and Baltic Sea can be traced back to the Fukushima disaster. Next slide. So more onto plate tectonics regarding Fukushima. The subduction of the Pacific plate beneath the North American plate created a large tsunami with a very large wave height. Subduction occurs when a plate slips diagonally at the edge of a tectonic plate, and this area is called a subduction zone. So subduction zones provide most of the power we need to move plates while inducing convection and overriding the mantle wedge. The mass subduction that occurred prior to Fukushima caused the Tohoku-Aku earthquake, and then a tsunami was triggered from that earthquake, and the tsunami triggered system failures throughout multiple reactors and components of the power plant. So the damaged fuel tanks allowed for radioactive material to be released into the environment through leaks, and scientists believe that the leakage of radioactive waste from Fukushima disasters never stopped, but rather slowed and still emits radiation into the ocean. Next slide.
So in terms of the remaining nuclear waste from Fukushima, in order to continue to keep the power plant under control and to prevent it from overheating, they are constantly pumping in water from the ocean to continue to cool the power plant. As of right now, there are 1.2 million liters of wastewater in storage tanks near Fukushima that need to be disposed of. The scientists there are making efforts to decontaminate this wastewater using the advanced liquid processing system. However, in order for this to be effective, groundwater and rainwater from the facility must also be prevented from leaking. And in my picture here, you can see the path of this water from the ocean through the liquid processing system and into the storage tanks. Eventually, however, this wastewater will need to be disposed of. So as of right now, the Japanese government insists that once this happens, the quality of the water will not be overly affected and it will still be safe to drink. However, the Chinese and South Korean neighbors are very wary of this process and are worried for their fisheries and the quality of their drinking water. As of right now, the Japanese government plans to begin releasing this wastewater in 2 years, slowly over the course of several decades. Next slide.
So as stated earlier, the majority of the contaminated water has not yet been released into the environment. However, radionuclides have escaped during the disaster and subsequently afterwards in the form of radiocesium. Radiocesium was unique to the Fukushima Daiichi power plant and is currently being transported by the Kuroshio and Oyashio currents eastwards, actually towards the Bering Strait. It's expected that the radiocesium will reach the Arctic Sea if following the trajected path. However, this radiocesium has not been detected in the Indian Ocean, which, if you can see based off of the image, the trajected path of it was kind of a great example of how currents and ocean gyres take effect on a large scale in the transport of nutrients in the Pacific Ocean. Because 70 to 80% of the radionuclides that were deposited after the accident were deposited over the West Pacific Ocean and subsequently followed that gyre path to the Bering Strait. Next slide.
Because of this nuclear disaster, the public's opinion on nuclear power has diminished and major investment programs are unlikely to construct a new line of nuclear power plants, especially in developed countries. There is currently much ambiguity about 8 probable units in 4 to 5 different locations within the US as of 2011. Elsewhere, current power plants' safety rules and regulations are being updated, and this is driving up general costs. The most expensive cost of nuclear power plants constructions are the initial cost or the capital cost, and relicensing of current and future plants are being made more difficult to obtain.
So, some of the positive impacts that have followed nuclear power plant disasters include the fact that the meltdown of the Fukushima nuclear power plant in Japan 2011 has since led legislators to prioritize a growth in renewable energy resources. This is going to be beneficial in preventing climate change by decarbonizing the energy sector and reducing the potential of growing environmental disasters that could pose threats to current and/or future developments in the nuclear power sector. So I'm going to introduce the future impacts of nuclear power. So some of the future potentials for nuclear energy is that it can include safer and advanced design systems. An example of this is the Integral Fast Reactor Project. This was shut down by the Clinton administration in 1994, but the basics of the Integral Fast Reactors, it was a new unique design for nuclear reactors that used fast neutrons that wasn't slowed by water, and it's known as the light water reactors. And therefore it can split the uranium atoms more quickly and continue the reaction for longer. Another advanced design system would be smaller nimble nuclear reactors. And it has the potential to become a very good competitor if there was ever to be a carbon tax put into the energy sector. Some of the innovations include advanced battery storage, demand management, and regional integration that is taking place in developing countries currently.
So when talking about the risks of nuclear power, there are three main categories that we want to look at. And the first is the economic issues. So many people will cite nuclear power as being a cheaper energy source, but many of these studies are actually funded by the industry and will leave out costs such as capital costs, which is the most expensive, taxpayer subsidies, and insurance costs. So when taking these all into consideration, nuclear power can actually be found to be 6 times more expensive than other conventional energy sources. Then the second risk of nuclear power is environmental issues. So these nuclear power plants use a lot of water to cool them, and this can cause a lot of thermal pollution in the oceans, which can have effect on a food web, causing a chain reaction. But this actually can be mitigated with choosing the right site for these plants, with the two main factors being the shoreline topography and the water velocity. And then the third category is that nuclear waste is hazardous to humans, so the threat of radioactive waste still exists, and accidents like Fukushima can really spark people being scared of it, but in actuality more people die from air pollution from fossil fuels than from accidents from nuclear plants. Next slide. And so on the left here, we have the LCOE, which is the levelized cost of electricity for 4 different countries and different forms of energy. And you can see the levelized cost of electricity is the cost of the plant divided by the electricity output. And so you can see in nuclear that it's lower for a lot of them, meaning that nuclear may be more expensive to go, but it's a cheaper long-term solution. And then on the right, it's just the CO2 emitted worldwide, showing that the United States is still emitting so much carbon and we have to figure out a way to mitigate that. Next slide.
So I'm going to be introducing the counterclaims to the feasibility of nuclear power. So according to the New Yorker article, some of the pros of nuclear energy include that reactors only require a small energy footprint to generate a lot of energy. It does not emit carbon dioxide or other fossil fuel pollutants. Nuclear energy abundance is on a global scale, and waste and radiation are minimizable risk, although they do exist currently. Radiation associated with nuclear energy isn't as harmful as it seems. It actually, a CT scan of the abdomen involves 10 times more radiation exposure than a nuclear power plant worker is exposed to in a year. And these are our questions. And now we will be answering questions whenever anyone's ready.
Oh, okay. Well, thank you for that. And I guess, does anybody have any questions for the danger zone? A good team name for talking about a nuclear disaster, I guess. Any questions from the audience? That was kind of a, I guess you were trying to present like a pro and con there in the last couple of slides. It sort of came across like a pro and pro, because on the one hand you're saying is lower danger, and so I mean, what do you guys think? I mean, have you formed an opinion about nuclear power and ocean systems?
I mean,
So-
sorry.
You can go first.
I was just the one that did the cons, and like personally, like I'm a supporter of nuclear energy. I just want to kind of give the other side, and those are the kind of risks that I found associated with it. But a lot of those risks can be mitigated with new technology.
Okay.
Yeah, I also I saw a documentary on PBS, and it showed the Fukushima disaster at length, and it showed behind the scenes footage that had never been released before. They took a couple years to be released because of legal issues, whatnot, but it really opened my eyes to the fact that one minor issue or someone's unwillingness to put an end to a lot of people don't want to risk themselves or their lives if issues were to arise, and as climate change persists, there will be greater environmental issues such as increased hurricanes, tsunamis, storms, and I just believe that unless we put in greater measures to kind of make it a very secure fort and locate it away from the ocean in particular and kind of supply its own nuclear pool of water where it can recycle that, I feel like it can be a possibility.
Yeah, so the theoretically it's a good option, but we haven't yet been able to implement a situation that local people feel comfortable with. I think maybe that's the way to put it.
Yeah.
Well, okay, so one thing that was brought up, maybe it was Abril who was talking about detecting Fukushima radiation in the Black and Baltic Sea. Were you sure you were talking about the Fukushima radiation, or was it another accident?
So I was talking about fish pollution or the radiation that's been seen in fish, just in the marine environment. There was a broad study. We can always go back to the slide. And yeah, it's at the beginning. But it was a study by Madrick et al. In 2018 that showed that there were fish populations in the Black and Baltic Sea that could be traced back to the Fukushima disaster.
That's amazing, because the Black Sea, that's a sort of enclosed sea. It's kind of hard to understand how, you could get all the way around the world like that in just a few years. So kind of surprised by that.
The research study was really comprehensive, and it was really interesting to me considering the locations, but yes.
Well, because of course the other, closer accident to there was another accident that was a lot closer to the Black and Baltic Seas. And do you know what that was?
Chernobyl, was it?
Yeah, so Chernobyl was another. Anybody ever see the Netflix series Chernobyl? You guys watch that?
No, but I heard it was really good.
It's
I'm really interested.
it's like a true fiction horror story. It's pretty amazing, and yeah, that released a lot of radiation. So I wonder how I wonder about that study, Abril. So I'd be interested to know, because I'm pretty sure there's still radiation detectable in the Black and Baltic Sea from the fallout. Atmospheric fallout that was released from the Chernobyl, and also a lot of radiation got into the rivers and was carried into the ocean that way. Okay. All right, well, I guess we'll just end it there. So thanks to everybody for these talks today.
I believe Zoe Prada has a question.
Zoe, yeah, go ahead.
Be mistaken.
I was wondering if y'all could go into more detail about how the seawall broke.
Yeah, go ahead.
Yeah, I guess that was also in my section too a little bit. So the seawall that was surrounding Fukushima was a 6-meter seawall. However, the subduction from the plate tectonic subduction that caused the earthquake and then the tsunami caused about a 41-meter, a maximum height of 41 meters for the wave.
41 feet.
41 feet, excuse me, for the wave. So it overcame the seawall And when it overcame the seawall, as I talked about a little bit, you started having problems with the reactors in the power plant. So basically the seawall wasn't built for the waves to be that high. And so the waves overcame the seawall because of the strength of the tsunami.
And also, I'd like to include in the documentary I saw, they had already been the company that owned Fukushima had already been notified 2 years prior to the incident that their walls were insufficient for tsunamis. And they said they were looking into it when in reality, nothing had been done or looked into because it was just an extra cost because those walls are also very thick. So yeah.
Yeah, and the other factor in all that, which you didn't mention, is that the pumps that kept the cooling water going, they were located underground. So they absolutely had to flood when the tsunami water came over there. And so it was the failure of the pumps to provide cooling water that caused and it was actually a meltdown. You didn't talk about what a meltdown is. Can you want to talk about what a meltdown is?
Yeah, basically from the documentary, I got that basically it needs that water cooling to allow it to stay at a stable temperature. If not, it'll very quickly heat up to the point where it's just going to start melting through everything down into the ground. And it's a very dangerous thing because once it's already melted through, it's kind of too late. You have a very short time where you can contain it until it's too late for anyone to even step foot. So that was something that was very wild, that they managed to get in a team of people to cool that down in the small time frame that they had. I found that very interesting.
Yeah, well, the radiation was so high in Fukushima that they couldn't even send robots in to investigate. Same thing at Chernobyl. So both Chernobyl and Fukushima were accidents that resulted in meltdown, which is like the worst possible case. And so the reactor dome, the protection dome, was breached and material was released to the atmosphere. And then also there was melting down into the groundwater. And I guess it's, the government says, oh, the water is very safe and it won't cause effects, but there's the group that, the societal group that's most concerned and that's really suffered there are who? Do you know which group it is that's really, been impacted by this release? And they've just decided that the Japanese government has just announced that they're going to start releasing the cooling water that they've been storing into the ocean. And, so what group is it that you think objects most strenuously to that?
Probably the people that are working in the fisheries of the area and the people that live in the area that are drinking the water nearby.
Exactly right. It's the fishermen, because their industry has just been totally wiped out by the release of nuclear material. And then the towns nearby have been closed down. Okay, we'll have to leave it there. These are really interesting topics, and I appreciate all the work that everybody put into making these nice presentations, and I've learned a lot from listening to everybody. Now, tonight we will put out the take-home midterm will be made available. There's going to be a lot of questions on the take-home midterm. The final. Excuse me. I meant to say the final. And so the final is worth 125 points in total, and the take-home portion of the final will be worth 50 points. And there are going to be a lot of questions. So basically, all of the quiz questions that you've had since the midterm, plus some quiz questions from the before the midterm. So the basic things that I want you really to take away, plus all the questions from the groups. So there's going to be lots and lots of multiple choice questions, which you'll be able to do on Canvas. And then there's going to be some diagramming and essay questions. But if you can get through all that, and I know it's a lot of work, but the idea is to really help you to study, to go back and go over all this material. And if you get through all that, the final exam on next Thursday will be really easy, or you should be really prepared for that. So that's the idea. So have a good attitude going into all this. I know it's a lot of questions, but you don't have any time limits. You can use all outside aids, but then when it comes time for the final in class, you'll have you should be familiar with everything that you're seeing. You will have seen it a couple of times already. Okay, so that's the idea, and that you get practiced in answering everything. So I want to say goodbye to this class. It's been Zoom. I know it's too bad. I really missed the classroom experience and the energy that comes in the classroom. But I appreciate all the work that you all have done. It's been a fun time to go through this and cover this material. I really care about this material, and I'm glad I've had a chance to both share the material from the textbook and share work from my own research. So I hope you'll all do well in the exam, and I hope you've had a chance to respond to the course evaluations, because that helps us out when we go to develop new material and teach this class again. So good luck, everybody, and I'm ready to write recommendations and things for students. I always get asked about that, and so I'll be happy to do that for you all. Okay, well, goodbye, everybody. Have a nice summer, I guess. Seems hard to say because it's still only April, but hope you have a good summer break, and hope all goes well for you. All right, goodbye now.
Bye, thank you.
Bye, thank you.
Bye.
I had a couple questions before I head out.
Thank you.
All right.
Sure, Joshua. Or who's talking?
Are there any other classes that you teach?
Yeah, I'll be in the fall. I'll be teaching issues in environmental science. That's 4017, and it's a similar structure to this course, except in the fall we'll be back into face-to-face classroom. So yeah, but the issues in environmental science is meant to be more sort of the global environment, not just on oceans. There will be, so there's a bit of overlap, because I think the oceans are so important for the environment, but it has more to do with sort of environmental questions. And it's also intended to be more of a discussion class. And so we do spend more time on that. So yeah, 4017 next semester will be a class that I teach.
Thanks.
So perhaps we'll see you.
Also, are there any other new updates on that whole Tampa Bay incident?
Yeah, I haven't heard anything lately, but they're looking at sort of nutrient loading, and there's a lot of concern about that. There's a lot of oyster farms and shellfish farms in the area, and the shellfish can help to control the algae, but if the algae get above a certain level, they can't harvest, so it shuts their harvest down. And also the effluent coming out of that retention pond has apparently got heavy metals in it. And so heavy metals, it's one thing for the shellfish to eat, to filter out the phytoplankton, but the heavy metals, that's no good, because that heavy metal loads can mean that it's really not healthy to eat that. So that's a lot of concern. The Florida Institute of Oceanography is collecting a lot of samples. They have their research vessel out there. And so there's been a big response from the university systems to that. I believe we're getting some samples here at FSU, but I'm not totally clear how that's working.
Heavy metals cause mental disorders, don't they?
Yeah, definitely. Well, methylated mercury causes birth defects, and all those things can cause neurologic damage and other sort of damages. But yeah, heavy metals are, once they get in the body, it's difficult to get rid of them. And so yeah, it's a major concern.
Do you think for the next maybe, I don't know, year or more, should I just avoid shellfish, or just to be safe?
I want to avoid shellfish in Tampa, but shellfish from other places are okay. I don't think that I think that's going to be pretty localized to the Tampa Bay system. But it still remains to be seen what will happen when the summer months come on. if that nutrient loading is going to produce a lot of harmful algal blooms, could very well happen.
Would those like heavy metals like spread to the rest of the Gulf, or would it be pretty localized to Tampa?
I would expect it to be pretty localized. Tampa Bay is pretty shallow, and so there's not a lot of tidal flushing. So I would, there's not big rivers running out to carry that stuff out into the Gulf. So I would think it's going to be a local impact, which is kind of too bad because that means it all stays in the Tampa Bay area instead of maybe being diluted with, river water or whatever. So it's not a good situation. And apparently there are, hundreds of these same retention ponds, and you don't know whoever is the landowner or the responsible party, it's up to them a lot of times to maintain the dams and the integrity of the lining inside these ponds and things like that. So, it's sort of an infrastructure thing, really. It's kind of a negative infrastructure because it's a potential hazard.
Yeah.
Okay, well, I got to get off. I got another meeting starting here. So good luck, everybody, and have a good summer.
Thanks for the great semester.
All right, thank you. Bye now.
This is a great class.
Glad
Bye.
you enjoyed it.